Let's explore Apache Flink. It's a powerful stream processing engine designed for high performance. Flink serves as a unified platform, capable of handling both batch and real-time data processing tasks efficiently. Apache Flink is an open-source, distributed stream processing framework. It is designed for stateful computations over both unbounded and bounded data streams. Key characteristics include low latency processing, which means minimal delay, high throughput, allowing it to process large amounts of data, fault tolerance, ensuring reliability, and exactly once semantics, which guarantees that each record is processed only once, even in the event of a failure. Let's compare stream and batch processing. Stream processing operates in real time with continuous data flow and low latency, often providing millisecond responses. It deals with unbounded, infinite data streams and is event-driven, processing data as it arrives. On the other hand, batch processing is scheduled to run at fixed time intervals. It focuses on high throughput, handling large data volumes with bounded or finite datasets, and primarily performs historical or past data analysis. Flink's architecture consists of two key components: the JobManager and the TaskManager. The JobManager coordinates task execution and includes the scheduler for task coordination, the checkpoint for state management, and the resource manager for managing cluster resources. The TaskManager executes the tasks. It comprises task slots for parallel execution, memory for data buffers, and network components for data exchange. Flink's DataStream API is the core interface for stream processing. It is equipped with a rich set of transformation operators that allow for real-time data transformations. A basic stream processing example includes creating a stream environment, reading from a source, transforming and processing the data, and then executing the job. The code on the slide shows how to create a stream execution environment, read data from a collection, transform the data to uppercase, filter data with length greater than 3, and then execute the stream job. Flink provides robust state management capabilities, offering different types of state, including keyed state for per-key storage, operator state for per-operator instance, and broadcast state shared across all instances. For fault tolerance, Flink offers automatic checkpointing, exactly once guarantees, and recovery from failures, ensuring data consistency and reliability. Flink's DataSet API handles bounded datasets for batch processing workloads. It uses the same engine as stream processing, but with different APIs for stream and batch operations, providing a unified platform. The example code illustrates a batch processing job involving reading a text file, flat mapping to split lines into words, grouping by the first element, reducing to count occurrences, and writing the output to a file. Flink is used in many real-world applications. These include real-time analytics for dashboards, business key performance indicators, and user behavior tracking. It is also used in Internet of Things data processing for sensor data streams, predictive maintenance, and alerts. Further applications include fraud detection in financial transactions for pattern recognition and instant alerts, and extract transform load pipelines for data transformation, migration, and warehouse loading. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.